Okay, we're going to get going now. So this last unit is inequalities. And it's going to be inequalities on a number line for the first few sections, and then it's going to be inequalities in XY space. Okay, but this first part is we're solving inequalities, which should be a lot like solving equations, like we did a few months ago. It just has like one minor difference when you're solving inequality. But another thing is there's also graphs that go along with these solutions. And when you solve equations, we didn't often graph the solution. So we're not going to do any quizzes today or tomorrow, and I don't know what we'll do when we get back. It'll be like TBD. But I think the test will be on the 11th of January. Yeah? There is an exam in this class, the 24th. Okay, so let's review inequality symbols. Right? You need to know these. You need to know what these mean, just as like you know how to read your name. I mean, you can't be struggling to say, what does this symbol mean? How do you say it? Greater than is this symbol here. Greater than is this one. Less than. Right? So, you mean that symbol, whether it's turned one way or the other, it's the pointy end has got the small thing on that side, right? And the part that opens up has got the bigger number on that side. 2 is greater than 1, which is the same thing as saying 1 is greater than 2, is less than 2. Okay, if you put a little bar on the bottom of it, then that means or equal to. So it's greater than or equal to, less than or equal to. So is 2 greater than or equal to 2? Yes, it is, right? That or equal to part picks it up. Is 1 less than or equal to 3? Yes. Yeah, it's the less than part that picks it up. So, I mean, we'll be using these symbols all over the place, and we just need to have a common understanding what they are. Okay, next. So, inequalities are solved pretty much like equations. You isolate the variable on one side by doing operations to both sides. They do have names when you do that. Like if you add things to both sides, that's called the addition property of equality. If you subtract, that's the subtraction property of equality. So for the ones that we're going to do today, which are only these two right here, really there's no difference to how you solve an equation. Now, these two, yeah, there's a significant difference when you solve those, comparing solving equations to solving inequalities. But for the ones we do today, it's pretty much the same. Right. What's that? You copy? And these are ones you should have copied. If you did that extra credit homework, that's what this was. Right? You already copied them. Okay? That's the... So when you graph an inequality on a number line, right, there's going to be two parts to it. There's going to be a circle, which is on the number, and then there's going to be shading to one side or the other. And the circle could be either open or closed. So you could see on this one here, it's showing x is less than 3, right? If it's less than, it's not less than or equal to, that's why you have an open circle on 3. Right? Open circle, less than. In fact, I'm going to use the symbols, no point. Less than or greater than, open circle. Okay, now the variable is x. You could think of the x as saying like the shading. The shading is less than 3. Okay, on the number line, where do you find lesser numbers? To the left or to the right? To the left. So the shading is to the left of 3. So that's why the shading it over here. and they got an arrow, it keeps going because it goes on forever. It's like if we were solving an equation, we might get an answer like x equals 3. The graph is just a dot on a number line, which is not interesting. If you're going to solve an inequality, you're going to have not just one answer, you have infinitely many answers, and that's got to be represented by shading, right? Goes on forever. Okay, if you have a or equal to, like the second one, x greater than or equal to -1, then you color in the circle, right? It's a filled in circle. So less than or equal to, greater than or equal to, right? I'll say closed circle. Again, you could think the shading, it's saying x is greater than or equal to -1. The shading is greater than -1. Okay, is that to the left or to the right? Greater means to the right. So that's why it's shaded there. I mean, another way you could think of this, if you solve an inequality with the variable on the left, then the inequality symbol is like an arrow showing you the way to shade. Like on this x is less than 3, that less than, since the x is on the left, the less than is telling you shade to the left. Over here, x is greater than or equal to -1. Since the x is on the left, you shade in the direction that points to, right? Points over here. Okay. Is all of this reviewed? Yeah. Pretty much? Yeah. So I thought. Okay, the highest temperature recorded in the United States was 134 degrees Fahrenheit at Death Valley, California in 1913. Use only this fact to write and graph an inequality that describes the temperatures in the United States. Okay, let's see. Well, so let's say T equals temperatures in the United States. T for temperatures. Okay, so we've got a T and we got a 134. What inequality symbol goes in between those so that we're describing all the temperatures in the United States?
Less than.
Is it just less than? Well, it said it equaled 134 at least one day, so it definitely has to be the 134. But it was never more than 134, so less than or equal to 134. Now that's a complicated word problem. Okay, so try this one. Similar kind of question. The lowest temperature recorded in Antarctica was -129 Fahrenheit in 1983. Use only this fact to write and graph an inequality. Oh, did we forget to graph? To write and graph. So I should have graphed over here. So 134 should have been in the middle. Should it have been open or closed circle? To the left or to the right? To the left. Shaded to the left. Okay, so go ahead and try that one. Temperatures, the lowest temperature ever recorded in Antarctica, which is probably a pretty good bet that's the lowest temperature ever recorded, -129 Fahrenheit. So write an inequality, graph inequality. Right?
Yeah, I sure did.
Okay, what's the inequality symbol that goes in between the T and the -129? Greater than or equal to. Okay. So it's okay just to have a number line, put that -129 in the middle. Is it open or closed circle? Closed. Is it to the right or to the left? It's greater than, that's pointing in that direction. There you go. Okay, so write an inequality that is represented by these graphs. These are mine. The next one is the you try. Okay, so the one on the left, definitely I'm going to use x as my variable, and it's -6.5, which is the inequality symbol that would describe that. Okay, it's greater than because it's shaded to the right. Is it or equal to?
No.
No, because it's open circle, it's just greater than. How about the one over here? X, there's an X and there's a 4. Because it's shaded to the left, it's less than. Because it's closed circle, it's less than or equal to. Right. Okay? So try these two. Come up with your own. Okay, what goes in between the x and the 8? What goes between the x and the negative 2.5? Okay. Okay. Any questions on that? Okay, shouldn't be. Okay, so again, these are things you should have copied in our after the homework, after the test homework. So basically, the addition property of equality means quiet. You can add the same thing to both sides and you get an equivalent inequality. So if that gets you along the way to isolating the variable and solving the inequality, then that's what you do. So addition property of equality. Here's an inequality that is not solved, right? X minus 5 is greater than negative 3.5. How am I going to isolate the x? Add 5. So, quiet please. The 5's cancel on the left. X. Okay, does the inequality symbol change because we just added 5? No, it stays the same. And what's negative 3.5 plus 5? 1.5. Right? Easy to do. Oops. There's your, you try. Try that one. So then I should have come over here. 1.5. It's open circle, shade to the right. Okay, now you do yours. Okay, what do you do to both sides in order to solve for P? Quiet, it's too loud. Felicity? Add 9.2 to both sides. So P is less than, what is negative 5 plus 9.2? 4.2. And then we got a graph. Open or closed circle? Left or right? Less than? Okay, I'm taking away classwork credit if I hear any more laughing over there. Okay. You guys asked to change seats, but obviously it doesn't work. Okay, let's try another one. So then subtraction property of equality, which means you could subtract the same thing from both sides and get an equivalent inequality. And there's nothing different about this than if you were doing this to solve an equation. So, solve. 9 is greater than or equal to x plus 7. We got to isolate the x. What do I do? Okay, we got a plus 7 with it, so I subtract 7. 9 minus 7, 2. The 7's cancel, and I've got the x. Okay, now no, this is a good point. Okay, so am I going to use open or closed circle? A closed circle. Am I going to shade to the right or to the left? Okay, so remember what I said before. if it's solved with the x on the left, then the inequality sign could be like an arrow pointing the way to the shading. This one does not have the x on the left. So when somebody said flip it, what you flip is the whole thing, right? You don't just change the inequality symbol. You make this x is less than or equal to 2. So 2 is greater than or equal to x is the same thing as x is less than or equal to 2. As long as the x is still on the pointy side of the inequality symbol and the 2 is on the opening side, it's still saying the same thing. Okay, now it's a little more clear. Which side are you going to shade? To the left, right? Because the x is on the left. Shade. Okay. Okay, so try that one. Okay, what's the one step to isolate the y? Subtract 5.5, right? Subtract 5.5. What did I do? I know. 5.5. Y is greater than, what is 6 minus 5.5? 0.5, right. Okay, then we graph it. Put a 0.5 right in the middle of that. Okay, open or close circle? Right or left? Okay. And, okay, you are checking a bag at an airport. Bags can weigh no more than 50 pounds. Your bag weighs 16.8 pounds, right? Find the possible weights, W, in pounds that you can add to the bag. So let's see. You have, your bag already weighs 16.8, right? You're going to add W, and what's the inequality symbol with respect to that 50? It's got to be less than or equal to 50. So if you wanted to represent this with a inequality, that's what it is. Okay, now solve to find out how much you can add. Minus 16.8. Minus 16.8. So these cancel. W is less than or equal to, say it again, 38.33.2. Okay. So that was an easy lesson. Yeah. Yeah, just a second. I'm ready for the